Right, okay, so what we were doing before the break is we were having a look at Unit 3, Waves and Information Transfer, Lesson 3, how is information transferred from place to place? And we'd started having a look at how computers basically talk to themselves. We had a little look at binary code, and you guys had to go at some homework, and I've got some homework sent in that we can have a look at together. But what I wanted to do was actually just take it back a little bit, because I know it was quite confusing for some of you. So what we're going to do is just start with a look at computers, because I think that's going to help you guys understand why we're learning about this in this topic, why we're studying computers and their own language in the first place, by looking at how do computers actually work. Now, I am not a computer scientist. I've gone off and I've given myself a crash course in how computers work, so I can try to explain it to you guys as simply and basically as possible. It's not going to be a big scary thing. Most importantly, how do computers transfer information? Let's start with Nana. Can you think of any way that computers transfer information?
I don't know. Electric.
Yeah, they use electricity. How are we talking to each other right now?
Energy transfer.
Nana, think more like, you know, when my computer gets really laggy or I might disconnect, why do you think that might be?
Not enough power.
Not enough power, maybe. P, you've got your hand up. P.
The Wi-Fi.
Yeah, the Wi-Fi. We're going to have a look not in this lesson, maybe not the next lesson, but maybe the lesson after. We're going to have a look at Wi-Fi and wireless ways of computers sending information to each other. But for now, thank you, P. But for now, we're going to have a look on how a computer kind of talks to itself, the way that you think your own thoughts. How does a computer transfer information kind of from the keys when you're typing to the screen to round its what we call CPU. So it uses something called binary code, which is made up of bits and bytes. And this is what we had a look at last lesson. So I'm just going to, like I said, I'm just going to take a step back and have another look at this in a more simple way. Because I know some of you got it. I can tell some of you got it because of the homework I got. And we're going to practice basic binary code, although I don't think we're going to get to that today. I'd be very impressed if you guys managed to get through that much material. We're going to have a look at pixels. Now, pixels is something that you're slightly more familiar with. That's I don't know if you guys can see that. Pixels are, remember the Pikachu? And we had a look at Mario as well. And you guys colored in some pixels for me in the last class. Pixels are how a computer can show an image. And then we'll check that you understand how do computers transfer information. Yeah, Wi-Fi on the internet, that big blue picture up there. So your homework check was to do with pixels, and it was to do with binary code in the most basic kind of sense. I asked you to use some grid paper or draw a grid or use Excel or whatever it was that you wanted to use to plan a design you wanted to draw in either black or white or two other colors. And then we were going to fill in the boxes with ones or zeros, depending on which box needs to have color in it. This one has a message, this picture here. Don't worry, Mikang, I've got your homework. It's on the next slide. This might help jog your memory a little bit. I'm going to turn on annotations. And what I want you guys to do is, using whatever color you want, except white, I want you to color in the ones boxes and fill in each of the ones boxes. So annotation is on. Can you guys please use the draw function to just color in all of the boxes that you can see with a 1 in them? I don't just want to blare. No blares. Just a little, yep, there we go. Okay. Beautiful. Okay. And stop. Right. Okay. This is so lovely, so neat and tidy. Bunny, you've got a nice easy question. What's my message? What does it say?
Wait, what do you mean?
What's it supposed to say? What letters can you see?
I don't know, because the letter look weird. I can't find.
Can you see my screen?
Yeah, I can see your screen.
Cool. Okay, so I'm going over in red.
Mm-hmm.
Okay.
Oh, that's H. That's
H. Good. And then you were only supposed to color in the boxes with 1s in them.
That's an I.
That's an I. So what do you think that my message is?
Hi.
Hi. Yep, that's it. That's all it was. Just nice and simple. So, Mei Kang sent me some homework, and I filled this in yesterday, I think it was. But again, what I want you guys to do is I'm going to turn it on, and I want you to color in the boxes, and only the boxes with the ones in them. I think that's right, Mei Kang. Yes, give me a thumbs up if that's right. Yeah, cool. That's what I did. Only the boxes with the ones in them, and to try and do it as neatly as you can, so you can actually see if there's an image, and then I want you to tell me what it is. So, drawing has been turned on. You're going to do this as a team, so it's going to be nice and quick. And off you go. And stop. Tyann, do you think we've colored that in as neatly as we could have done?
Maybe.
Maybe not. What problem could there be if we color in the wrong boxes?
I couldn't figure out the code.
Yeah, exactly. We can't see the pattern. That's okay. So, I had a little go. I'm going to turn off, and I tried to do this in paint to try and make it neat. Now, that's what I colored in. And I'll tell you what, I think your homework, so you can lead us. Okay, what is it? I kind of see an alien or a spaceship on the left-hand side. Would you?
It looks just like I'm out of ideas.
You're out of ideas? Okay, no worries, buddy. It's your homework, but I suppose you might have done it a little while ago. That's okay. Pardon?
I found it on the internet, so nothing.
Yeah, that's okay. I thought that was the case, but at least you sent me something in, so thank you for doing that. I have a look at how computers work, really basic look at it. So first up, who remembers what this is? I told you I'm starting super simple. Hey, Dina, can you remember what this is? This picture? There's some labels to help you.
The battery
Uh-huh.
go in the lamp.
Yeah. And then what connects them?
The wire.
The wire. Good job. Can you remember what that's called? This is a super, that's right, Dina. This is a super simple circuit. Well, you recognize this, I hope. Yes? Belle, do you recognize this?
Recognize that?
Do you remember me drawing something like this on the board? Maybe not with those symbols, but drew some wires and a little picture for the battery and a little picture for the lamp or the light bulb.
A little bit.
A little bit. That's okay. So that's a very simple circuit. And then I've made this a slightly more complicated. I'm still going for Belle. Belle?
Yes?
What's in the second circuit that isn't in the first circuit?
It has a switch.
Good job. Yeah, so it's got a switch. So this one's a bit more, yeah?
Light bulb.
Yeah, it's just got a different symbol. I couldn't find one with the same symbol, but the battery picture is the same. So cool. Thank you, Belle. We've got one very, very simple circuit. We've got another slightly more complicated, but still very simple circuit. And then here, Ming, can you see the third circuit? It's a smaller picture with more things in it.
Yes.
Yeah? Can you tell me one difference between the third circuit and the other circuits?
It has more light bulbs.
Yeah, it's got more light bulbs, it's got more wires, it's just a bit more complicated. We know what a circuit is. We've made circuits in class. Ice cream, what kind of energy flows through a circuit? Is it heat energy or light energy or electric energy?
Electric.
Yeah, okay. We're looking at a computer and it uses electrical energy. We'll look at that more in detail a bit later. The computer is basically lots and lots of circuits, all kind of connected up together. And this is still too simple for what a computer looks like. This, yeah, I can see some of you reacting to it. Okay, so this scary looking squiggly, shapy thing of lines and everything, it's just a complicated circuit. Vinny, have you ever seen a computer that looks like this?
Yes.
Or a part of a computer? Yeah. Whereabouts was it? Was it in the screen or?
Inside.
Yeah, it's inside. So this is a black and white picture of this. Vinny, do you know what this is called?
No.
No, that's okay. This is called the motherboard. And it's basically just lots and lots of complicated, very clever circuits that are all connected up. That's all it is. There's a space for battery, There's a space for the fan, which you can see to keep it cool. And there's a space for something called the CPU, which we'll learn about in just a second. Belle, don't worry. Don't worry. You don't. Belle's just said it's like the hardest math thing in the world. That's why I said we're just doing the basics. Like, don't panic. I just wanted to show you that a motherboard, so the computer, it's just made up of lots of circuits like this. Okay. This is like this bit in here. Okay. And we've seen circuits before, and I just wanted you to understand it's electric energy that runs around it, that powers it. So instead of powering the lamp or the light bulb, it might be powering something else over here, or maybe it's powering the fan. And yes, it's super complicated looking, but that's all we're going to do on it, I promise. I'm going to ask Heejong, can you tell us again what kind of energy goes through a circuit or the circuit in a computer? What kind of energy? Is it motion or heat or electric? What kind of energy flows from a battery to through a wire? Here, when we plug things into the wall, Heejong, you know when we plug things in, what kind of power, what kind of energy are we using? When we plug something in, when we need to charge our phone, or if we need to charge the laptop, what kind of energy do we need to use? Nana, can you tell us?
Yes.
Nana, what kind of energy do we use in a circuit or in a computer?
Electric.
Yeah, that's all I wanted you guys to know. We use electric energy. Electrical signals are sent around the motherboard, just like a circuit. Actually, I want you guys to read this out for me. I've only got a couple of points. I'm going to turn your microphones on.
Electrical signals are around a motherboard.
Good job.
Most of the work is done in the control central processing unit. CPU is like the
Right, yeah. That's the most important part of that part, okay? So everything happens in the CPU. CPU is the boss. It's like the brain of the computer. What does it say next?
It transfers electrical signals into information.
Information. Good.
How can we compare that to the human body?
Yeah. We were having a look at lenses, and I want you to keep your microphones on. We've only got a few minutes left. I want you to keep your mics on. Before the break, we were having a look at lenses, looking at convex and concave lenses, and we were looking at a certain part of the body in relation to lenses. What body part were we looking at?
CPU.
So lenses, what do lenses affect? Can you remember? We were looking at refraction and reflection, which are to do with, when we were looking at lenses, what body parts did we have a look at as well? How do we observe anything?
Eyes.
Yeah, with our eyes. Good job. How does the information get from our eyes to our brain?
It travels.
It does travel, yeah. How does our eye send information to our brain?
Look.
What does it do?
Look.
Yeah, we look, and then it sends information to our brain through electrical signals. Now have a look at what I've circled. How does our eye send information to the brain?
The optic nerve.
Yeah, along the optic nerve. How and what does it use?
It transforms electrical signals into information.
Yep. Thank you very much, Minkai. Yes, I know it looks very scary and everything, but the reason I wanted to show you guys this is to show that it's actually quite similar to our brains work, in that it sends information through electrical signals. And I'm going to show you this on the next one. Computer versus brain. Why am I showing you this? What is the point? Let's wrap this up in the next. How are computers and brains similar, everybody?
Signals to send message.
Yeah.
Hello.
Information.
Yeah, they both transfer information. Which one do you think is faster, guys? Transfer information. Good. Do you think a computer or a brain is faster?
Brain.
Okay, use raise hand if you think it's the computer. Okay, hands up if you think the brain is faster. Oh, I love your confidence, but sadly, no, Kiddlywinks. Computers work faster. Computers transfer information even faster than our human brains do, although our brains are really, really fast. We're going to have another look at computers and how it talks to itself and how it transfers information using electrical signals. But for now, you're free of me. Can you please say goodbye to each other?
Bye.
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 Bye-bye.
Bye 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 bye.